All right. Good morning, good afternoon, wherever you are. So, welcome to this live stream about vibe coding inside the AOSP. So, I've had a bit of fun with this. Hopefully, this is useful to you as well. The chat is open. If you want to give me a mic check there in case there's any issues, let me know. I've been having some sort of intermittent mic issues, so if that shows up on your end, just let me know. All right. Um, this is supposed to be a fun sort of a presentation. I've had quite a bit of, you know, playtime with Claude on this, and it's been entertaining and actually sort of enlightening as to where this can actually sort of take us. So, without further ado, let me get started. And if you're watching this in the future and you've got any comments, just post them in the chat there in the comments. We'll see if we can get to them a bit later on. All right. So the slides and some of the code that I generated are things I'll share a bit later on. I just wanted to concentrate on the presentation for starters, and we'll try to share the stuff a bit later on. All right. So anyway, the slides, as I said, will be there. In case you're not familiar with my work, I wrote the embedded Linux book for Riley in the early 2000s, wrote the embedded Android book for them. About a decade later, I've got some code in the kernel. I've been playing around with a whole bunch of stuff, and anyway, helping people take Android and Linux and put them in all sorts of wacky devices from time to time. So you know, all fun all around. So let's actually start here with straight with the meat of the topic. So I got into this with a specific purpose in mind. I actually had a need that needed to be addressed. And as I was looking at trying to solve that, I was like, hey, maybe we should try this Claude thing. And it turned out to be quite some fun and quite a few lessons learned there. So, you know, hopefully some of that actually is useful to you as well. So here's the itch to scratch. I was sort of trying to revamp my AOSP debugging and performance analysis class, which the content's online on my website. And the idea there is to find a way to have tools that deliberately load the system up and then allow people who are trying to measure performance or whatever it is that they're doing see the actual impact of that. So like the two sides of the same coin there, you know, load the system up, see how it goes, sort of in a visual fashion in as much as possible. So in other words, enable developers to sort of study where the edge cases are and learn how to use all the tooling around in AOSP to actually investigate those sorts of things, and of course use that as a learning surface on how to optimize your systems, which these days with some of the things that people are doing with Android is pretty ambitious. I mean, you look at say, if anything else, the automotive sector, a lot of people are pushing the limits of what Android can do. And so it's interesting in those cases, or you know, any head unit, whatever, VR headsets or whatever. At some point, you need to actually sort of measure the performance of the system you're looking at, or if anything else, you're seeing some weird stuff happen and you need to understand what's going on, right? So the difficulty here lies in the fact that Linux and Android, I mean Linux with kernel, and Android as a layer on top of Linux are actually fairly effective at good optimizations. So in most cases, they'll do a best outcome of whatever load is on there. The trouble is they don't always do that, and when they sort of fail, it's hard to sort of catch exactly what's sort of going on. There are some tools inside AOSP that have been historically there to load up the system and see what's going on. Some of them I found are outdated or just not powerful enough. They don't actually load up the system sufficiently for what I need them to do. They don't make it fail in a reliable fashion. And when I started looking at this, one of the things that was sort of like worrying for me is, okay, how much effort is it to actually create this sort of tooling, right? And of course, corollary to that, maintain it and whatever, and so on and so forth. So, regarding Claude, there's a lot of, hype about it. Obviously this is the Anthropic product or service, if you want. And there are many incarnations of it, so I really relied on just Claude.ai, so like just the web interface. I'll get into this stuff later on. And you know, I had heard some, you know, secondhand feedback that people liked it. And I had, you know, I've been extensively using ChatGPT, which does a relatively okay job for many things. But coding, you know, it's not bad at doing it. It's just, it's not like, it's organized as a conversational thing mostly for you know, a lot of, you know, either human stuff or general research or whatever. And, you know, in terms of programming, it seemed that people were using Claude for this. So, and it, of course, it had a free version, and I'm like, hey, why, what I got to lose to give this a try? So the first thing I did was to try to just kick the tires. It's like, okay, what can this thing actually do around AOSP? Is it able to do anything that is actually sort of useful? And my goal here was, you know, let's look at something that requires deep enough internals to generate something that can show me the limits of this system, right? So I asked it to create a system service, right? Which is, if you've been doing any sort of Android internals work, is something that you've probably either had to do or touched or whatever, right? So pretty nitty-gritty detail inside the AOSP. And it actually sort of kind of surprised me. It actually came up, and I'm not showing you the whole sort of output there, but for every one of those things that is in there, it actually generated the code for it. So it gave me an AIDL file, an implementation, registration with the system server, you know, the client-side manager, the code to actually talk to this thing, and the whole thing. And I'm like, wow, okay, this is really interesting here. This thing actually is able to sort of, you know, move at the level that you need to do some interesting work inside the AOSP. And of course, you know, it goes in and gives us an explanation of everything it's doing and why it's doing that, and yeah, the whole thing, right? Cool. All right. Okay, let's up the ante here a bit. You know, so the next thing is, okay, this example assumes that the system service is part of the system server. What if I want it to be launched as a standalone application? And it delivered. Essentially, it gave me, you know, a standalone persistent app, you know, that has a manifest file that, you know, the thing starts, registers itself and runs independently. And then it says there's another approach. You can actually launch this natively from an RC file. And it sort of then, you know, kind of equivocates and explains why you'd use one versus the other and that sort of business. I'm like, okay, maybe this realistically can do a good job for what I'm trying to do here with the AOSP. So let's actually give that a try. And so the next thing was like, okay, I started a new prompt and said, okay, I'm working on you know, this AOSP performance analysis class, and I was wondering if you could give me some help. And sort of like, this is what it spits out, you know, kind of voluntarily saying, hey, well, what do you want to do? This, or that. Okay, cool. Interesting. So the first thing I wanted is a system service that sort of blocks on a call or has some sort of background task that's using up, you know, CPU usage and is configurable. And as a starting point, I sort of uploaded an example system service that I use in many of my classes, saying, okay, here's an example system service. Go and munch on this. And it delivered. Essentially, gave me, you know, a README file about what it did. The AIDL file, the Java system service, the client, and build integration instructions is how you actually merge that into your AOSP. It's like, hey, that's cool, right? And you know, if you look at it, if I look at my system here, and I do sort of a service list, and I look for, this is a slow service, right? It comes back, it's running, and I actually have a CMD slow service to control this thing, or I can do dump sys slow service, and it's just, you know, doing its thing in the background, gives me some help. I'm like, all right, we seem to be on the right track with this thing. Let's continue on. And initially, of course, you'll see this a bit in the screenshots I've given of the prompts, is I'm trying to sort of, it gives something, and I'm like, okay, that's not quite exactly what I want. Can you just, you know, add this or change this or whatever? And I'm sort of watching what it's actually doing. So in this case, I wanted to have, you know, the CMD, which it wasn't there initially, to be able to control it. And I said, okay, can you add the CMD thing? And not only does it do that, but it actually gives me sort of a tutorial right there. And actually what I found is that it devised a proper CMD with the proper sort of, you know, sub commands and everything else, and it looked, I mean, it looked professional in terms of what it could deliver in terms of just designing the command line interface for the system service that that I had. So this sort of surprised me. It's like, okay, you're not only giving me code here, you're showing me how to use it. That's clever, right? And so I go a bit further there, you know, and sort of there's a bit back and forth between some of the later stuff and the earlier stuff. So I started with the service and I went off to do other things, and I came back to it. And I said, hey, give me a revision that does this, like allows me to control whether the calls are blocking or not blocking and blah, and sort of, or the hog in this case, you know, see if the CPU hog that's running in the background, if it can be controlled. And it did that, right? And then of course, as interestingly, of course, you try to build the code and it doesn't actually always work. This often happened actually. It gave me some code and all sorts of weird things happen. Like for example, at some point it generated some C code or C++ code, and it looked okay, but the problem was that essentially it was not compiling because it line wrapped on an open quote, and it was like, okay, so I just went in the file, just removed the line wrap, and the thing compiled. So it does strange things like that, but it's not too bad at actually sort of taking the errors and doing something with them, like in this case, right? So essentially I gave you this error. I can't remember what it spat out after that, but whatever it was, it actually was useful. So the next thing is like, okay, I've got a system service that runs this thing in the background. Give me something that actually sort of I can run to load the system up in terms of CPU usage, all right? And initially what I did, as you can see here, I said, hey, there is actually a CPU eater in older versions of AOSP. Maybe you could use that, right? And so it comes back and generates this tool that it calls CPU eater underscore multicore. I eventually found the name way too long, so I just snapped it in and said, okay, let's call this CPU hog. It turns out there's some sort of GitHub project that's also called in the same thing, but totally unrelated. In fact, the whole operation of Claude here was always based on the CPU eater multicore. It's only later that I sort of changed it, and even when I told it, hey, I changed the name, it kept using the old name or something like that. Anyway, it doesn't really matter. But anyway, generated actual really cool little tool here called CPU hog. Essentially, if I run this, it initially, so I'm running Cuttlefish here with 4 cores. It tries to not use up all cores, so it uses 3 of them, and I found that not to actually load the system up enough. So I eventually asked it to actually give me a bit of control over what it's doing, and now I can actually control the number of cores and the number of threads per core. So usually what I end up doing with this is I just load it up with 4 cores and 4 threads per core, and that actually loads the system pretty nicely. All right, this is quite an interesting load. It's just, I think it's just doing a while one loop, doing some sort of math in the background there, whatever it is that it's doing. I don't really care. At the end of the day, it's just sort of loading up the CPU. And that's actually, the comment I just made is pretty much kind of one of the things that I found myself doing a lot with this that I sort of didn't like, which is I don't care what it's doing, right? It's like, get me what I want, just get out of the way, right? And that's both interesting and troubling because I'm not exactly sure what it's doing sometimes, and I sort of kind of vet the code sometimes, and I sometimes don't. At the end of the day, it's like, okay, just let this, you know, get to fruition there, which has some ramifications I'll come back to later on. But you know, this mentality of I don't care what the code does eventually kind of becomes natural when you're using a tool like that, and I'm not quite comfortable having to get into that sort of mindset. Anyway, so it generates this thing. Quite after a couple of prompts, essentially it also gave me a tutorial. And one of the things I realized actually while putting this presentation together is that it lost prompts that I kind of clearly remember being there. It seems that based on my research, it will sort of clean up old prompts that when it compresses the sort of conversation or whatever it does, because the conversation's been going on for too long. First they tell you, use multiple prompts on the projects and blah, blah, blah. And I'm like, whatever. It's all the same. In my mind, it's like all the same conversation, but then it ends up being super long conversation, and LLMs in general don't like that. ChatGPT doesn't like it. This guy doesn't like it either. So whatever. It is a byproduct of at least the current generation of how LLMs sort of proceed. And I'm like, okay, so you gave me the code. Can you give me the Android build file for it? It does, it, obliges and sort of generates the thing, and gives me the BP file. And then I'm like, okay, so let's go back to the client of the system service that talks to that system service and does a bunch of stuff there. And can you give me an application that does this, right? And first I ask it actually this, I give it this prompt, and sort of it misunderstands. It gives me actually an output for the CPU eater or CPU hog that I just gave it. I'm like, okay, no, that's not what I meant. I meant for the actual application, and then it obliges. It sort of gives me the actual output there, and then essentially on the cuttlefish there, I've got this sort of slow service client here, so which is sort of has this scrolling view, and sort of at this point, you can get it's actually getting primes from the slow service. So actually the slow service in the background is calculating primes. And the thing is, of course, if you try to load the system up, then you can actually start seeing that it slows down, right? And actually gets pretty sluggish in its actual performance. And that was my goal. I mean, again, I'm trying to sort of get tooling and utilities that allow people who are trying to learn about AOSP debugging and performance analysis to actually see the effects of what happens when the system is loaded. And you can kind of see that pretty clearly here, that there's some, and I actually sort of like, if I keep this on top for a second here, and I just do Control-C here in the background, it immediately comes back to something a bit more normal in terms of refresh and so on and so forth, which is precisely what I kind of wanted to have. It's not as compelling as I wanted to, but it's still pretty good. And the other thing is, of course, if I control the, so for example here with the, so if I do something like, so I can actually sort of cripple a thing. So I can do something like CMD, slow service. Let's actually stop the hog. And what you'll see is that the primes have stopped refreshing here because essentially the hog is no longer working. I can actually start it back, and then the numbers start refreshing again. Let's stop it, and actually let's do another thing that's even more sort of stupid, if you will, is let's actually make it blocking, right? So now it's blocking. The application made a call to the system service. The system service is actually not responding because it's sort of blocking. And now if I sort of touch the actual interface, it should give me an ANR because the application got an input. It's not responding to the input. Give it a few seconds. Usually it'll happen, and then I'll actually get myself an ANR. If it behaves as it should. In the past I've been able to get it, but here we go. There we go. So close the application. The application is not responding. All right. So that's for this. The whole manifest and everything, and it was missing some files actually at some point. I can't remember is this one or was another application. Anyway, the other thing I wanted to see is to enable people, or wanted people to be able to see, is how much system load has an impact on the time it takes to load an application, right? So you start an application up, whatever way it is, right? If the system's pretty loaded, then it's going to suffer from this. And so the question is, can I make this visible in some way, shape, or form? So, this is, in this case, it's this little utility that I've got here. Actually, let's go back to here, this shell, and, sorry, forget this. Let's go back to here. This is the actual start thing. So put this on top, and sort of it's loading it up, right? So essentially, this is essentially how much time it takes to get to the onCreate, and then the other number on the right is to the first actual frame being rendered, right? And then you can sort of kill this off. Where's that? For stop. And then I can sort of play around with this, start, stop, start, stop, and then essentially, let me start it again. What it does is actually sort of has a history of all the launches, right? So you can see the bar graphs at the bottom. Was there no hallucination at all, the CPU hog implementation? Not really. For the CPU hog thing, it did pretty well. There's other things where I'll get later on to another example where it really went off the rails in all sorts of directions, and was sort of totally, you know, confident in its explanations as to why things were going sideways and so on. Anyway, we'll get back to that later on. So anyway, you can see the bar graphs here sort of showing me the like last launches. And then, of course, if I load the system up, sorry, that's not what I wanted. Put the CPU hog on full throttle, then actually let's start, sorry, stop it, start it. And you can see now the worst case, the actual first frame came in way much later. Stop it, start it again. Bam, you know, you can see the numbers sort of deteriorating here pretty fast. Stop this, start it over. Yeah, it gets bad and bad, right? I mean, that's normal, right? The system is loaded up, so you can definitely see the penalty of the actual sort of system being loaded in the startup of this application. And of course, you know, if I go out here and just stop the CPU hog and essentially start this thing up again, I'm sorry, stop it and then start it up again, you know, oh, the numbers are actually pretty bad, pretty normal again. You know, we're sort of back to, you know, the expected sort of startup time. So if you're trying to study, you know, what is the impact of system load on your overall system performance, this is pretty useful, right? It gives you pretty sort of a easy way to measure how much impact the system load has on your application starting up. All right. And so the uncool thing that happened with this is that I gave it the first prompt there, and then I didn't put in the screenshot because it was gone. It sort of generated the stuff out, and it wasn't even compacting at that point. It's just I sort of had downloaded all the files it gave me. It just sort of allows you to download a zip file. So I downloaded the zip file, and I went back to it for something, and then I noticed that the prompt I gave it and the output with full explanation that it gave me were gone. And I was like, what just happened here? And you can see like the exchange here. You just lost the query I made. And it's like, oh, I'm sorry, whatever it is. And so I uploaded the zip file, but then the entire explanation just went missing. So okay, so I've got these files here. I no longer have the actual original explanation where it generated these files, so it's kind of lost in the ether here. We no longer have context, right? So of course, you know, this is the sort of thing that happened quite a bit. I tried to build it, it didn't work. Copy paste the actual error, and then it sort of says, oh, the problem is this, and you fix the thing, and you go on. And here's one actually sort of like that hit me in two layers. So I do something, right? I fix this because it's actually sort of telling me to change a resource. So I change the resource. I go back, and it doesn't build, and I'm sort of, you know, just automatically just copy paste the error, put it back in there, and then when it pops this explanation up, I'm like, wait a second, it figured out I'm using Emacs, huh? And then the next layer is like, holy cow, I'm not even thinking here. I'm no longer an intelligent developer here. I'm no longer actually taking the time to look at the error output at all. I'm just copy pasting. I mean, if I had taken 2 seconds to just look at what this error about, I would have caught it. I was like, okay, that's right. This is a temporary file from Emacs, but I didn't even see it, right? And so that's the sort of thing that sort of kind of the sentiment that grew on me as I was using this is like, wait a second, this thing is sort of like robbing me of my analysis. And I mean, it isn't doing it, I'm doing it. I'm sort of delegating like automatically here to this thing, the actual understanding of any errors. I'm not even thinking at this point. And it came in pretty fast, right? It's sort of like pretty quickly as I was sort of starting to do stuff. It's like, okay, forget it. I don't really care about the error. Just take and send it off to Claude, see what it says, right? In this other case, this was a pretty funny one. So I said, okay, I fixed that. And then there's an iterator that's like broken, right? So it's like, oh yeah, I know what this is, and sort of figures out what the issue is, and it gives me a change, right? And I apply the change, right? And I say, wait, I'm still getting the error. But then this, it's like, you know, wait, that line is outside, blah, blah, blah. Could you paste the current state method so I can see the exact, exactly where I is being captured? I'm like, wait a second. All right, so I didn't actually patch it as it said I should have. And then I would go back and look at the code. I was like, all right, that's true. I missed something, right? And that's the sort of thing where again, this automatic sort of mindset of, just throw the thing there and try to make it work without looking at the code. It becomes a second nature very, very quickly with a tool like that. So yeah, and then like just general stuff. Can you give me like the commands like the ones I just did here to start and stop the load demo on the command line? It sort of obliges and give me. I like this. I mean, it's able to figure out like really detailed, or contextual responses to what you're asking. So it generated code. It knows how to start the code. It's like, wow, okay, that's brilliant, right? Yeah, so some more details like, is there a way to do that without the on create, blah, blah, and gives me the am start-w and so on. Yeah, so this is the last prompt I gave it, I think, where it now chose the 2 times, the one for first frame and the one for on create, as you saw, all right? So that's essentially a way to see how much, the load of the system does to actually goes to impacting the starting of an application. At a second step, I wanted to see actually how the load impacts a live application, not the load of it, but it's actually how much impact an application that is running is going to suffer from, something running in the background. And I said, okay, generate me an application that you can see visually what is actually sort of going on. I'm going to run the CPU reader in the background, and I want to see it actually do stuff. And you can see it thinking there. It's like, okay, how it works, and what's the student's going to see on screen, and it decides to do a Mandelbrot. I'm like, wait a second, I didn't tell it to do this. It just came up with this idea of using a Mandelbrot to present the actual load. I thought this was pretty nifty, right? And the actual application it generates is actually pretty cool. Let me actually show you this. So let's go back here and open it up. So this is the stress view right there. And so yeah, just rotate this in a way that's visible. There we go. So it's doing a Mandelbrot. You can see it's doing X number of frames per second, and it generated all this code without me telling it what to do. It's just it did this, right? And I'm like, okay, that's pretty cool. Let's actually load the system up, right? And if you load the system up, you can actually see the frames kind of dropping right there, and the Mandelbrot slows down, and it's got this scope, kind of like oscilloscope kind of output in the bottom there, showing you where things are bad. And of course, if you stop the actual sort of CPU hog, everything sort of returns back to normal, which is a pretty easy way to see exactly the impact of CPU load on applications that are already running. This was pretty relatively easy to come up with, right? The next one was harder. So hogging down the CPU is easy. Hogging down the memory, that's a bit trickier. So essentially, I gave it a prompt saying, okay, give me a tool, kind of like the CPU reader thing that we did before, but now I want this thing to actually just hog the memory down, right? This one took many prompts, some of which I think had disappeared, because when I kind of was trying to capture some of this for the presentation, I'm like, wait, I'm pretty sure I had a long conversation about this thing with the tool because it wasn't actually doing what I wanted it to do. But anyway, so the idea here is sort of similar to the CPU hog, but in this case, we're just going to eat up memory, right? So the devour essentially just goes up, ramps up the thing, and tries to eat up as much memory as it can, as quickly as it can, and as you can imagine, this eventually gets killed by the out-of-memory killer because, hey, you know what, at some point the Linux kernel just can't take that no more, and it will just kill it off. And you can see actually the system sort of like, in this case, sort of jamming up, because effectively it's sort of running out of memory. Give it a second or two here, and essentially the killer is going to come in and just kill that thing to get rid of it, which is kind of expected. This is not sort of too surprising about what happens when you try to eat up too much memory. It gets killed. But that's not what's interesting. What's more interesting, and just give this a second here to sort of come back on its feet, or I have to go home or whatever. Yeah, it died. Anyway, as you can see, this is sort of like if you're eating up the entire sort of memory space, then yeah, sure, some stuff is going to happen. So the more interesting part here is actually ramping up. So something that's actually gradually taking memory. So ramp up to say 90% in say 30 seconds, all right? So you're going to see the percentages here are increasing, And that one is the one that it took it a few iterations to get right. Because it wouldn't go up to, it would not be able to get up to the percentages I would give it. It's like, okay, I'm trying to go here, and your tool is able to grab the memory if I devour it. In other words, it goes in and does the whole thing really, really quickly. But if I give it, some time span, it actually never reaches that percentage. And it eventually came back with relatively cogent explanations, right? Well, first of all, okay, the tool itself, but then it's like, hey, when I use MemEater, it goes up to 97 very quickly and holds, but if I use to ramp, it only gets to say 60% and then just doesn't go up, right? And then it gives me an explanation about what's going on in the kernel, right? This is a classic Linux overcommit issue, blah, blah, blah. And then, it root causes it. So what's happening is Linux overcommit key-swap decombination means that even memset pins pages allocation, the kernel's page reclaim daemon can sadly swap out anonymous pages that haven't been touched recently, blah, blah, blah. And if you go through what it's saying, it's just, it starts a thread in the background to keep writing the chunks in memory and then essentially kind of consume it. And I'm like, wow, okay, this is pretty smart here. And of course, it's convincing in its explanations. And I'm like, I think this sort of makes sense based on what I know, but it could get it wrong. I don't have no idea to sort of understand whether it's really getting it right or not in a verifiable fashion if I don't know what I'm talking about, right? So I know sufficiently to say this sort of makes sense, but I'm not, a memory internals guru of the Linux kernel, so I can't vouch for this 100%. But it kind of makes sense, and you can see it actually is able to get to the actual percentages that I now am actually asking for, and does hold to those things pretty okay, right? And then the flip side of it is, okay, I've got myself a tool that does this. Now I want to have a visualization tool that allows me to see how this actually sort of impacts the system. And so we get here to, let's go here to memstress. There we go. So this is essentially loading up the sort of buffers to try to sort of render some images and keep them around. And if you sort of try to hog the system down, what you're going to see is that it eventually is going to start degrading its ability to get those memory buffers to actually render what it's doing. And the combination of that, so nailing down the CPU eater with the load demo and the Mandelbrot thing, those were quick, relatively quick, in comparison to this memhog and the actual memstress test that you see here. That took many more iterations to get it to give me something that actually works. And I had to go back to the prompt and say, okay, no, this is not working, this is what I'm seeing, this is not working, this is what I'm seeing. And it eventually sort of continued sort of chunking on stuff until I got to what I was looking for. Anyway, so now if I kill the memhog, it sort of goes back to normal, which is pretty much what I was wanting to see. And it tells me, this is my plan, this is what I'm going to do, and then you forgot this. And this actually, I found this one funny. It's sort of like, it gave me some files, but then forgot some of the files in the application, like those files are missing. And then it says, they were already part of the output, I just didn't give them to you. It's like, okay, so where is it that you actually put your output there? Yeah, and then sort of a visual sort of quirk there. I could see slider, I couldn't touch it. Sort of a couple of other things there that, as I said, quite a few prompts there before it eventually got me to something that's working, right? And then I turned to something completely different, which is I want to generate ANRs and tombstones, right? If you're doing any sort of internals work, then you've probably met those things. ANRs were generated when an application just doesn't respond to user input, and the tombstone is when some native code actually crashes. I'm like, okay, I want to generate those on demand. And it did a pretty good job actually with this thing called Crasher, I think. Let me just bring this up here. So this is Crasher. And essentially here, if let's try to do this spin here. It says wait X number of seconds, touch the screen, and if you give it a couple of seconds more, what's going to happen is that it's actually going to generate an ANR because it's locked up doing whatever it is that it's actually doing there. The ANR actually ends up in the data. There we go. Here's the ANR, and it sort of came back on its feet data ANR. There's ANRs here that have been generated, like 2 of them today. The other one here is just to get a tombstone, and if I click on any of these buttons here, usually it's bam, it actually kills it. So this is actually under tombstones, and sort of that's pretty reliable. And the tombstones worked sort of out of the box immediately. The ANRs not so much. The ANRs I had to go back to it a couple of times and say, okay, your ANR buttons are not working, and eventually it got me something that actually, yeah, I'm still not getting any ANRs. Okay, this works, layout's not good, blah blah blah, and it fits them all, right? So I mean, for those sorts of things, it did a pretty good job. Now this one here, that's where it really went off the rails. So there used to be some tools that allowed you to see which PID is hosting a system service. I mean, if you've done any sort of internals stuff inside inside Android, the common thing to do is to do the service list like this to see the system services. And you know, well, the common confusions here is to assume these might be processes, these might be threads, and I'm like, oh, that's not quite right. In order to understand that, you have to go look at the code, see where they're started, and so on and so forth. And the problem is that it's not actually obvious to get this information live from the system. So a long time ago, we had this thing called Binary Explorer that's still on GitHub that we haven't maintained in years. That sort of used Node.js to sort of show you the network of connections on Binder. If anybody wants to update it, have fun. But you'll see sort of our friend Claude here did a not too bad job with giving me something that does the same sort of information in a different format. And there are some other tools from third parties that have been able to do that. But in this case, right, so the initial prompt I gave it is this, right? Can you give me an Android shell script that is able to retrieve the PID and process description by looking into BinderFS to associate this info using system service name as input? And this took it forever to converge, and it was hallucinating. It was giving me all sorts of explanations as to why the reasons the scripts it was giving me were not working. And at some point I'm like, you know what, maybe a script's not a good idea. How about you give me some C code instead? I think you can do this and that with the C code, and it comes back and says, oh, you're so right, blah, blah, blah. And then sort of kind of starts in that direction. And eventually I was able to actually get it to do this. I don't remember where it's at there. Right, binder svc info. So let's do this in a tree view. And you can see here actually what it does is it goes in and actually looks up the PIDs, and it tells me which system services are actually running under each of those. So, you know, PID, you know, 1043, which is the media server process, has the media player, resource manager, resource observer, netd has these things, and, you know, of course, as if you've done any sort of internals work, you know, the system server has a whole bunch of them, and it sort of gives them all. And then essentially, I sort of continued working on the prompt, you know, to give it fancier stuff. So let me just read the question here. So, I used Claude Code with Opus 6. Did you experiment with other frontier? No, I did not. So I stuck with the default one. I think it's. I'm not sure if it's Opus or Sonnet. I'm sorry. I can't. So I didn't actually bother looking at the prompt too much. But yeah, sort of like. For the, actually what I ended up having to do very early on is to switch over to the pro mode. Otherwise the free thing just, I mean, after a while, after a few prompts of what I was asking for is like, I hit the cap pretty quickly. And so I ended up going with the pro mode. And for most of the things I've done, it did a pretty good job. And again, I remember looking at the actual model I was using, but I can't recall which one it was. But it seemed to be the decent one to use for this sort of work. And you know, I wanted to have more information, like for example, you know, give me some more information about the processes themselves. So essentially, system server, this is a command line, this is executable, and blah blah blah. You know, information about the process. I'm like, okay, that's cool, right? And then I was like, hey, maybe we can take this like a step further, right? So I have a command line tool that is able to get the system services with their PIDs. Can I have a shell script on the AOSP that actually matches those two actual possible implementations in the AOSP? And it generated me a script for that. So this is a Python script here. svc pi, and I want to see a tree view, right? And look at what it does. So it actually goes and fetches the tree of the actual things, and it gives me candidates of implementations. So okay, this is Bobudaware. These are the possible implementations. This is the EIDL description. These are the actual possible implementations. Interestingly, of course, you know what it's doing is finding all the variants of the API that are under hardware. You know, this is the one. This is the current. If you've done any sort of work in those directories, you kind of understand what's going on here. And then eventually it gets to the actual system services themselves, and then shows me where the actual code is underneath the framework-based services, and so on and so forth. It takes it a while to do that because it's sort of searching through the through the actual code base. And I had to coach it quite a bit for this one because it was sort of going all over the place. I'm like, you're forgetting the device directory, you're forgetting this directory, you're forgetting this. Now your output's broken, that sort of business. And again, I haven't looked at the shell script. Actually the Python script to see what it's actually doing. It was like, it gives me the output I'm looking for. I don't really care, right? And for the kind of tooling that I'm doing here, actually, like knowing the nitty-gritty detail of what it does to get this right, wasn't like sort of super on the top of my list. It was kind of like, I just want this thing to work, if you give it to me, then I'm fine, right? So yeah, a bit of lessons learned and I haven't been using this for months, but I've been using it enough to get a good grasp, I think, of what it can do. So for AOSP work, it's pretty interesting what it can do. I've not sort of plugged it into my workstation with Claude Code, which I guess would be the natural extension of this sort of thing. But for what I've seen it do, it gives you sufficiently convincing explanations. Whether it gets it right or wrong, it seems to sort of know what it's talking about, right? And if you stick with it long enough and you know what you're doing, right, you can actually get it to generate some interesting things, right? But the troubling thing, of course, is when you tell it that it makes a mistake or did something wrong, it still comes back with explanations, right, as to why. Oh, that's true, I forgot this, or that's true, there's this thing, and then blah, blah, blah. And sometimes actually does interesting things. It says, okay, can you run this command for me and give me the output? It'll give me an idea what's going on. I'm like, okay, that's interesting. So this was an interesting twist on some of the prompts that I had. If you do use this for any work, at least on the web front, do realize that it will lose stuff, right? Don't rely on this. And if I recall correctly, I was reading, I think it was an essay by Tim O'Reilly, where he was saying that he sort of also lost some stuff as he was sort of talking to Claude. So, be aware of that. Of course, don't believe what it says. Check for yourself. And it will make you feel dumb, not because, you are, but because at some point you become passive in the process. And that's what happened to me. It's like, at some point I'm like, whatever, just, oh, error, copy paste, let's see what it says. And as you saw, sometimes it was just my own distraction. It's like, okay, that's right, Emacs generated a temporary file. So things I didn't try, kind of like as I was saying, I didn't try running Claude Code, so sort of local on my actual sort of code base, or integrating Claude into an IDE, or trying to run multiple agents, and like when designing the thing, when coding it, that sort of business, or even skills. Somebody was commenting on LinkedIn, I believe, that somebody was maybe looking at possibly plugging ADB as a skill. Hey, that would be interesting. I mean, I guess if I was running it local, a lot of the things that I just did here, it could figure out on its own. But as I was sort of getting into that, it was kind of fun to see what it was really doing with when I copy pasted stuff into it. So overall, my feeling is that I'm sort of just barely scratching the surface of what I could do with this. Very interesting stuff, but really two really big questions, right? Is who the heck owns the copyright to this material, right? And I sort of posted a question about this on LinkedIn, and I got all sorts of questions in all sorts of directions. From the, it's all mine to, in the UK it's copyrightable to, well, in the US it's not, or to the terms of conditions from the providers say that you own everything. And I'm like, okay, but there's no definitive answer here. I have no idea actually whether I can sort of claim copyright on this stuff. I mean, I own my prompt, I guess. According to the Copyright Office of the United States, anything that's machine generated can't be copyrighted. At least that was my reading of it. Not lawyer. This is not legal advice. Talk to competent people. But that was sort of my reading of it. But then in the UK, it seems to be copyrightable, according to somebody who was commenting on my post. So I'm like, okay, so what happens if two jurisdictions have two different opinions? Who wins this, right? Anyway, TBD. I've got no idea. I mean, the other thing was, my feeling from other conversations was it seems people are sort of assuming the horse has left the barn, and it's already out of control. I don't know. Time will tell. And the other thing is, how do I maintain this code? I didn't write it. I have no idea what it's doing. I kind of know. I looked at some of the stuff, but it's not something that I feel that I own as a developer. I mean, the code that I've seen it generate is clever in places, but if somebody had to quiz me as to why did you do it that way, I have no answer, right? It just did its thing. And again, for this sort of thing that I was doing, the disposable nature of it isn't too bad, I guess. And if it broke in the next version of the AOSP, I'd just probably re-upload the code and say, hey, I switched over to 17. What do you think? And maybe it spits out a whole bunch of files that actually work for 17, or I just coach it into doing it. And that's a kind of weird mode of development to think about. What I've seen is some people say, well, okay, you upload the specification to it, you upload the test cases, and if it passes your test cases, then it's all good, right? And I'm like, yeah, kind of, not really. We don't know for sure, really, what it's doing. It could be corner cases where it's broken. I mean, especially in the security area, in terms of securing code. If this is something that's supposed to be secure, I'd not be too comfortable with this. There's another post I just did, I think yesterday or the day before, of some website that's apparently running some AI generate code that says, oh, we texted this code to your phone, pasted into these boxes. It's like, oh, wait a second, you're not actually supposed to put the code in the website, you're supposed to send it to the phone only. So that's the sort of thing. So anyway, my takeaway from it was it's a really good amplifier. So if you know what you're doing, it'll get you faster to where you want to go. If you don't know what you're doing, it'll just amplify Dunning-Kruger's, like make you believe that you know what you're doing and you're going to go in the wrong direction. So, of course, a lot of people are like, oh, is this going to take my job away? I don't know. I mean, to an extent, my feeling was that if I knew what I was doing, it made me faster. But if I didn't, it would just push me into dead ends or deliver something that seems to work, but then sort of dies on me 6 months later. That's where, I'm not too sure what's the what's the final outcome here, right? I think it gives me velocity, right? That's my feeling, right? But where it takes us afterwards is TBD. Agreeing, I have been trying to debug on-screen mirroring issue due to recent Ashman MFD transition. Yeah, so it is going to help you move faster for certain things, or figure out, if you're stuck somewhere and you don't know how to get out of it. If the answer has been out there, because of course, they call this AI, but at the end of the day, this is just statistical analysis, right? So they just train this on vast amounts of information, and given the sort of amount of effort they do to train the model, it gives you answers that are coherent with the state of the art. If you're attacking a new problem or something that's not been done before, it can associate things that don't exist, right? The binder SVC info thing that I did is a prime example of that. I was like trying to push it in a certain direction that not too many people, I guess, have done, and it was sort of going in all sorts of ways. It took me like 23, 24 prompts to get to the actual sort of thing that I wanted. And across every one of those, I was like, oh, okay, give me some code. Let me just take this code, try it out, see what's going on, and come back. It's not working. There's this problem with it. So if you're doing stuff that lives at the edge of what exists, this is going to make you move faster, but it's not going to replace you. Maybe because it did not. Yeah. So yes, of course, access. Oh yeah. Okay. So the following comment was essentially that it did not help much in the debugging of the issue that the person was having, maybe because it didn't have access to the entire code base. That's entirely possible. So just again, continuing on the thought I was having there, if you know where you're going, this can help you. But if you're working on things that haven't been done or things that are difficult to understand or debug, like for example, let's say you're writing a driver, right? And you're writing a driver based on the data sheet from the manufacturer, and the data sheet has an error. The LLM can't help you with that, right? Only your sheer understanding of deep embedded systems can actually sort of help you navigate that sort of thing, right? So yeah, that's pretty much the sort of like what I've got up to this point with this playing around. I'll put the slides up, and of course the tooling that all the code bases that I got generated there, of whom I have no idea who owns it, available out there a bit later on. So if you've got any sort of comments on that, essentially feel free to post in the future in the sort of discussion threads on the YouTube video. And yeah, that's pretty much it for me. I'll stick around a minute or two here, see if there are some follow-up questions or comments, and otherwise we'll sign off after that. All right. So shoot anything that you got. There's also been a few comments already, which I think I addressed most of them. So let me know if there's anything you'd like me to talk about or anything you'd like me to answer. Yeah, I usually wait like a minute or two because the sort of streaming makes it sort of delayed when it reaches the actual audience. All right. Well, I guess that's a wrap. So thank you all for having attended. I hope this has been entertaining. And once again, if you've got any sort of follow-up comments or anything like that, feel free to post them in the comments, and we'll take them from there. All right. Thank you so much. Take care. Bye-bye.